always behave well with Word docs. I think it's supposed to work with Google Docs, if anyone's really into the Google stuff. Okay, here's a question. The secant of 135 degrees, how would you find that? Well, first off, what would you find instead of secant? Can anyone tell me what they would find instead of secant? What would you find instead of secant? Like, what's secant paired with?
Cosine.
Cosine, thank you. So you would do like 1 over cosine of 135. So what you would find is that, okay? So I'm going to do the cosine of 135. So if you see any of these, this is how I want you to do it. Okay, draw your reference triangle. 135 is in the second quadrant, right? There's 135. So if you plop the triangle down, okay, you got to figure out your reference angle. And this is what we talked about the other day. What would the reference angle be at 135? Can anyone tell me? Like, how far are you guys with a reference angle? Remember, how far are you off the horizontal? How far are you off that horizontal?
45.
You're 45 degrees off it. Everyone agree? 180 minus 135 is 45. So what you end up with is a 45, 45, 90 triangle. I'm sorry, this isn't showing up well. Which, again, is one of your 2 triangles to memorize. Remember your legs. Radical 2 over 2, radical 2 over 2, hypotenuse is 1. Okay? A problem like this, guys, is always going to be asking you to use one of those triangles, okay? Now, here's the question. Do either of these sides get a negative sign? Which leg would get a negative sign? I guess that's my question. Can anyone tell me? Let's see if you remember. Think about it in terms of x's and y's. Which one gets a negative sign?
The bottom one along the x-axis.
Good, Taylor. Yep, because you went left. Okay, so that gets a negative. The other one is positive y. And how about the hypotenuse? Is the hypotenuse ever negative?
No.
No, say no. No, it's not. So now the question said cosine. Okay, so cosine is adjacent over hypotenuse. Okay, adjacent is negative radical 2 over 2, and the hypotenuse is 1. It's always from the reference angle. Is everyone good with that? You're going to use that reference angle? Okay, but that's not the answer. How do you then find the secant, guys? You then flip it over, right? So it'd be negative 2 over radical 2. And you could simplify it, but you just flip the fraction over. And sorry, when I've been recording lately, I know I have bad handwriting in normal. I'm well aware. It's really kind of glitchy when I'm trying to record and present too. So all you do is you take your answer and flip it over. Okay? You guys okay with that? That help a little bit? Remember the 2 triangles you have to know. Okay, are that, and then we'll do one with the other one. This printed out wrong. Let's just do the cosecant of 210. Okay, so cosecant is paired with sine. So I would write this down, 1 over sine of 210. So let's draw 210. Okay, what quadrant is 210 in, guys? What do you guys think? What quadrant is 210 degrees in? Way to be active and participators. Hey, Sam, Aiden, Heller, thank you. There you go. You know, I'm telling you guys, it feels good. You're up early. Actually, you're not up early. It's 11 o'clock. My God, I've been up since like 5:15. Okay, I mean, you're just up. You're at them. You just okay. So you draw that piece of the bow tie. 210's over here. You plop your bow tie down. See how I did that? Remember, your triangles, no matter what quadrant you're in, you draw the appropriate piece of the bow tie. Okay, so now you have to figure out, okay, 180, it goes 90, 180, 270, 360. What's the reference angle? The reference angle is this little guy right here. So what's that reference angle going to be, guys? Anyone have any thoughts? How far out is that? Good, Aiden. Right? Yeah, 30. It's 30, right? It's off of the horizontal. The reference angle is always how far off the horizontal you went. That's really important. Is everyone okay with that? Okay, so if it's 30, your other angle has to be 60. And then this is that other triangle that I said you had to memorize. It's right here. Okay, opposite 30 is always a half. We'll write it down again. Opposite 60 is always radical 3 over 2, and hypotenuse is 1. Okay, across from 30 is always a half. Across from 60 is always radical 3 over 2, and hypotenuse is always 1. Now with this one, do any of the sides get negative signs? Think about your x and y. Are any of those sides negatives? What do you guys think? Any negative signs there?
Yes.
Go ahead,
Well,
Taylor.
The 1/2 is negative and the one along the x-axis.
Good. They're both negative, aren't they? Because you went left and down. Okay. So now we're doing sine. So from your reference angle, sine of 210, we're not going to do this problem here, so don't worry. Sine of 210 is opposite over hypotenuse. So it's negative 1/2 over 1, negative 1/2. Okay. See you, Sarah. Thank you. All right. But that's not what it asked. It asked for cosecant. So all you do at the end, guys, so you'd say the cosecant of 210 is negative 2 over 1. You just flip it over. Or you could just say negative 2. Okay. Now remember, I'm supposed to be teaching this class to you guys without a graphing calculator. I get it. Okay. Watch. If you come over here under the trig button, cosecant. And then remember, if you are in radians, just hit the little degree symbol. See? Yeah, that's a lot easier than probably doing the work, right? But, you know, if you have to show your work, this is how you show your work, okay, guys? This is what I want to see. Okay, real quick. Let's just, here, those two triangles, in case you forgot them or want to write them down again. You have a 30, 60, 90, and a 45, 45, 90. So your sides are on a 45, 45, 90. Remember, same angle, same sides. Radical 2 over 2, radical 2 over 2. On a 30, 60, 90, you have a half, radical 3 over 2. A half is always across from the 30, and 60 is always across from radical 3 over 2. Again, these are the only two you have to memorize. I promise. Promise, promise, promise. Okay? And that's it. The 5 or 6 of you that are doing the dual credit, this is, you know, what you'll have to make sure you know. All right. Any questions? Did it help going over a couple more? Again, we're you know, these short days, and I don't know how much you're doing in your other classes. Some teachers just have check-ins, others give work to do. I'd rather just like do a few-minute review, make sure we're good, give you guys a chance to ask questions. Again, this now is in your notes. This is super helpful. We're going to work on this, the converting to radians. We're going to work on that a little tiny bit today and then mostly tomorrow. But this chart is really good, and it's just all of it is off the pictures. Okay? So, and you don't even have to memorize, you know, some kids memorize these three and then just know that these are the reciprocals. Okay? All right. Real quick, I'll just start out with this. Did you guys do radian to degree conversions last year at all? You guys remember that in your Algebra 2? Now, see, again, maybe you did it, but it might have occurred during lockdown in March and April when, let's be honest, who was doing a lot of work then? Thank you, Aiden raises his hand. Adriana, yeah, you were. But I know not everyone maybe didn't get their full educational experience. So real quick, here's how you convert. And I'll give you a little proof. Do you guys remember this formula from geometry? Circumference equals 2 pi r. Does that sound familiar? Or circumference equals pi times the diameter. But remember, 2 pi r is a circumference. So what we do is they basically put the two systems on top of each other. So here's what you know. You go 0, 90, 180, 270, 360. That's degrees. Okay? Well, what they're saying is if the circumference is equal to 360 once around a circle, then 2 pi is equal to 360. So 0 is radians, and then 2 pi is radians, okay? So that's what we call it. 360 equals 2 pi. Okay, it's just another, like, if you put maps on top of each other. Does that make sense? If you overlaid systems, okay? And it comes from this. 360 is around a circle. That's circumference. Okay, well, around a circle is 360. The formula is 2 pi r. Oh, on the unit circle, the radius is 1. So then now 360 is 2 pi, 180 is pi. Does that make sense? Half of 360 is 180. Half of 2 pi is 1 pi. 90 is half of 180. If 180 is pi, what do you think 90 degrees is in terms of pi? You want to take a shot at it? What do you think 90 degrees is?
Pi over 2.
Yeah, good. 1/2 pi, or a lot of times we write it as pi over 2. And then 270 is between 180 and 360. It's between 1 and 2 pi. It's actually 1.5 pi. Right? One writes it. There's 3 pi over. Okay? So those are the main ones you should know. Okay, and really the important thing is right here. Write this down. Pi equals 180 degrees. I'm going to write that down. Pi equals 180. Okay? So here's how you convert degrees to radians. It's simple. You multiply by pi over 180 and reduce. Zach Warner, is everyone having that issue? Really? Can you see the screen?
What you're writing is like really lagging for me. Like you're writing and like it takes like a few minutes for me even to see what you're writing.
I don't like any of you anymore. That's all I'm going to say. I don't like any of you. I'm kidding. That's a joke. Laugh. Okay. No. All right. Well, I gotta do. All right. Hold on. Just let me see if this helps. Hold on. I'll be right back. Let me try to get off of this and then try it. Hold on. Can you hear me? Is that laggy?
It's a lot better.
That is so annoying. That is just, that is so weird. Okay, well, we're obviously not going to finish. Not that it really matters in these days, but let me just see if this even works, and you can just tell me if it's working now. Anastasia, thank you for your patience. Was anyone being naughty in the chat or anything that I need to like go back and investigate? Okay. I don't need any like cyberbullying or something happening in the chat, or just be nice to each other when I get kicked out of meetings, please. It'd be very helpful. Okay. Go from radians to degrees. You're going to no, hold on. No, see, it's still not. Oh, hold on. You're going to multiply by 180 over pi and reduce. How's that? Is that okay? Is that back to normal? Is that better?
You're not presenting.
Oh, shoot. Ugh. Oh my God. If this is how the rest of the day is going to end, that's it. Calling in sick and saying, kids, you're on your own. Let's see. Hold on. I just want to make sure it's good because I have another class coming right in. Okay. Multiply by 180 over pi and reduce. How's that, Miss Ford? Better? Or anyone?
Yeah, it's better.
It is? Okay. All right. Well, sorry we didn't get through as much, guys. Not that we would have done much more. We will pick this up tomorrow starting here. Okay. We're going to do, this is really important. You need to be here. We're going to do converting and the values of trig functions. So please make sure you're here ready to go tomorrow. Okay. Work on your math Excels. And the handful of you that I asked about the test, that wasn't like a, oh, it'd be great if it got done. It'd make me happy. It's like a, hey, hello, let's go. You know, but I try to say it nicely. It's a friendly, gentle reminder. So if you got an email from me, check your email. Let's get the work in, please. I want your grades to go up. All right, I'll stick around if anyone has any questions last minute. Otherwise, I will see you guys in the morning. Okay, have a good day.
Wait, Mr. Prinzi.
Miss Ford.
Can you please go back up to the notes?
Yeah.
Because I couldn't write down.
Which part, hon?
At the top of the day 3 notes, like up a little bit.
Up further?
No, down. It was right where you were.
Right here?
No, down. Yeah, right there. Okay.
Okay.
All right. I think that's it.
Okay.
Wait, what is that? Is it say 3 pi over 2?
Yes, 270 is the same as 3 pi over 2. Yep. 3
Okay.
pi over 2 is the same as 1.5 pi. One and a half.
Yeah.
We'll go over that tomorrow. We'll make sure we're good.
Okay. All right.
See you
Thank
later.
you. Bye.
You're welcome. Bye-bye.